here we go. So we're putting in this big disc and then dividing it up into a washer by pulling out an inner disc. So can you see the red? Here's the red radius. Notice it touches this line, and I always call that XY. And that meant I went over X and up Y. And that didn't seem to help us much on that one, but it'll become more important on these kinds. So here was my radius on the outer one. The blue is my radius on the inner one. So go ahead, see if you can set up your integral on your own. So you're going to figure out what are these going to stack up from and to. I'll give you this much, pi. And here's the outer, you're going to need the outer radius. For the larger radius, I guess we would call it the outer radius, going to be squared, minus the inner radius squared. See if you can look at that and come up with what that pink radius is, and then what the blue radius is. See what you can do with that. All right, one of these is quite a bit easier than the other. Morgan, which one is the quick one?
The blue one?
All right, what is the length of that blue line, no matter which inner disc I pick?
3.
It is. It went from 3 to 6, didn't it? Mm-hmm. There's no way to get that with a formula. You've got to draw it, unless you can envision all that in your mind, and I doubt that will always work, maybe on some. So the inner disc wasn't too bad. Did you see that it was 3? All right. The outer disc, however, is a little different. You've got to come up with an algebraic expression that has this length. So, Gianni, any thoughts from your brain?
I put down that it was 6 minus x.
All right, very good. This value, would you agree, between my two thumbs is 6? Do you agree? From here to here is 6? And what is it from here to here?
X.
X. So if you want this, isn't it 6 minus x? And that's why I drew in x over y up as that point, and I always draw that in. As long as I've done these problems, which is about 61 years minus, say, 20 years. That's a lot of years. I still draw that point in, and I go x over y up. I still do that. And so 6 minus x, and that's going to be quantity squared. And, Brendan, are these dy or dx discs? Like if this was a big penny and it was laying there, with the thickness of the penny, right, would be, they'd be stacking up like that, and so their thicknesses would be dy. And we have to mess with that. So back here we know everywhere there's a y, everywhere there's an x, we can put in a y squared from the problem before. So I'm just going to go in here and do y squared. That's a little yuckier than the last problem because you have a binomial squared. So remember there's 4 steps, or you can FOIL or do the quick method that I've taught you and get that down to 3 steps. And now we need to know what they're stacked to and from. And what do you think on that one, Erin? They're going to stack here, 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 and here's the top. Here's the top. Because remember our original problem.
0, right?
It starts at 0. But where is this top part? The original.
Would you have to go back to that equation that we used?
Yeah, what are you going to put in there?
We're still using y equals square root of x, right?
Right.
It would just be y squared.
Yeah, we need a number. We need a number here. So we know that this is the original problem. Remember, before we drew in all these discs was this area, and so they're going to stack up starting here and ending here, and that is on our curve y equals square root of x. at the value of x equals 3.
Would it be square root of 3?
Again, it is. Alright, were you able to get that or some parts of that before me?
Kind of, yeah.
Trying, yeah.
Just
Alright.
not
I didn't get the
Alright.
6 minus y squared, like that part.
Alright, now this is a little work. You have to square binomials, so you get 36 minus 12y squared plus y to the 4th minus 9, combine like terms, take the integral, throw in these things, and I'm not taking time to do that. It's all baby stuff. So let me give you the answer. You can entertain yourself trying to get it. 84 square roots of 3 over 5 units cubed. But let's just practice setting them up. That's what the calculus part is. Well, there's calculus in the middle of it, but it's just baby calculus. Let me assign you a couple of these and then just allow you to work on them. And I can help you with your homework, setting that up as well if you were unable to do some of them. So, let's see what I want to add. I would like to add some like this where we're going around other lines. Let's see. I had these written down here. Maybe I didn't. Alright, I'll have to look in the book. What time are we at there, Brendan?
we are at 6:42.
Alright, let me just pick some from the book. Sorry, Jonathan, we're at a little pause here. Alright. I need something like this where we go around other lines. So I see one on 12. So we'll do number 12. We'll do 12C and 12D. And let's do just one more. We'll do that one that we started. What number was this? 11? There's another one on 11, that 11C. Right. Alright, so this is the same section, 7.2, and there's 3 of those to do. Alright, now when I say do them, I don't mean just set them up. You actually crank it on out, but for now, I'm just showing you the setup to speed it up. Alright, Jonathan, that's all you need from us today. I hope that you're well and that you can make it in tomorrow. Oh, no Calc tomorrow, is that right?
Oh, yeah.
Yeah.
Alright, you got till Friday to get back here. See you then. Bye-bye.